Okay, so quiz 6 had one of the lowest scores. Part A had actually, even in our group, Part A had surprisingly low scores. Bottom line, don't let the numbers scare you. There's a lot of numbers in this, but question A really just wants to know if the percentage of the population really has a 9.8% heart attack rate. So that's why what you're testing for, your null hypothesis, is that the population is really 9.8% as some researcher chunk actually thinks it is. So what we need to find is the p-sample. P-sample is going to be the number of successes, so the number of heart rates, if a heart rate can be counted as successful, as 145 over 1739. This is your p-sample of 0.0834. If you remember from the last quiz, we've used this to, or not the last quiz, I believe it was 2 quizzes ago, that we used. We need to find the standard error for a percentage. Just take the square root of p of 1 minus p over n, gives you 0.0019, gives you your standard error. Again, all of this is detailed on that one sheet which he wrote for us, so make sure you just follow that. All you're doing is test for one population percentage. Then you find your z-score. So your z is your p-sample minus what the person thinks the mean really is, 0.098, over your standard error. And you get negative 7.68 as your z-score. Not going to waste my time looking that up in a z-table. We know that that's essentially got a 0% chance of occurring. So we're going to reject the null hypothesis, and we're going to say that the population doesn't really have 9.8% heart attack rate. Okay, so continuing on quiz 6, question B. This is where you are looking at multiple groups and their percentages and trying to compare if they're all the same. So this is where the numbers can be a bit finicky. Make sure you set up a table to keep your answers really clear. But let's start at the beginning. What are you testing for? You're trying to prove that the happiness and how happy people said they are does not have an effect on heart attack rate, and that any difference is just by chance. So that is your null hypothesis. Your p overall, which is what we found last time, is the total number of heart attacks over the total number of people in the group, which is 0.0834. So then next thing you need to do is you need to set up a table. I put up to here just because I was rewriting it. You might not need to, but it might help you to keep things clear. So what you need to do is you need to find how many successes do you expect, how many failures do you expect if all of the groups have the same overall heart attack rate. So for example, in order to find this right here, I took the success rate of the entire population, which is 0.0834, and multiplied it by the n, which I don't have here, but the n was 341 for group 1, or the sum of these two. So 341 times 0.0834 tells me I would expect, if all of them had if the population had the same heart attack rate, I would expect there to be 28.4394 heart attacks for the number of people who rated their happiness as 1. So you do the same thing across the entire board, no pun intended. Then next thing that you do is you need to find the number of failures. This is where a few people in our group lost points. Even though you looked at successes, make sure you pay attention to the opposite, which are failures. So you need to multiply. You basically can do this in 2 ways. You can subtract, you can take, where's the piece of chalk? You can take n minus your number of expected failures. Or the easier way is probably to just, again, go n times 1 minus your p overall. A little tip for a question like this, if you're using a TI calculator, or particularly a graphing calculator, plug it in as a function. So for example, go to your graph, put y1 is equal to 0.0834 times x. Then all you need to do is you need to compute, you insert, for example, for the first one you need to insert 341, and it'll just keep giving you output. Saves you a little bit of time with your calculator. Alright, moving on, so with your number of expected failures, again would be 1 minus p overall times n, okay? You might want to pause the video right now at this second to copy all this down because I need to move on to the next board. Alright, so moving on, as is outlined in the little sheet that he prepared for us about inference testing, the next thing you need to do is you need to you need to find your observed minus your expected squared over your expected for every single thing that you calculated. So what we calculated here, we calculated 10 values right here, okay? So what you need to do is you need to find that for each, and you need to find O minus E squared over E for each one of these values. Which is what I did here. I kept it in a table form just to help me keep everything clear, but you don't have to. But the bottom line is when you do, so these are for your successes and these are for your failures. So for example, for this first one, you would take your observed, which was 41 successes, subtract 28.4394, square that and divide it by 28.4394, and that gives you this term. So that's what makes this question really a pain in the ass, is that you have to do that for each and every one of these. But when you finally sum those up, you get the term C, as is outlined on the handout that he gave us. You get C is equal to 11.574. You need to compare that to a chi-square test with 4 degrees of freedom, because we're testing, we've got 5 variables, or 5 groups, so subtract 1 out from there. And then basically you find that the p-value is less than 0.05. So what we're going to do, we're going to reject the null hypothesis. The null hypothesis said that all 5 groups had the same happiness rate. So we're rejecting that, meaning that happiness does indeed affect your rate of heart attack. So that would be our conclusion in the real world. So moving on to question C and D. The first question asks, people who are happy are less likely to develop heart disease. That's just a statement of fact. Less likely doesn't imply causation, so that one's true. Part D, however, implies causation, implies that we should be happy and that would decrease heart attack rates. We don't have proof of that, so that one's false. Don't be stupid. If you're taking a quiz and you can't solve part A and B, but you see in true false, make sure you guess. Especially for something like this, make sure you guess true for both of them or false for both of them. It just increases your chances of getting it right.